we need to prove the following. So we'll start from the left hand side of a given equation. Now here what we'll do, we'll multiply sine squared theta cosine squared theta to each of the term within the parentheses. The first term will be sine squared theta times cosine squared theta whole divided by, so here we have secant squared theta minus cosine squared theta. Now we know that secant function is the reciprocal of the cosine function, so that means in place of secant squared theta we can have 1 over cosine squared theta minus cosine squared theta, plus for the second term we have sine squared theta times cosine squared theta multiplied to it, so that will be in the numerator, divided by, we have in the denominator cosecant squared minus sine squared theta. So cosecant squared theta is the reciprocal of the sine function, so we have 1 over sine squared theta minus sine squared theta. Further simplification is going to give us, so we're going to multiply both numerator and the denominator with cosine squared theta, so we're going to get sine squared theta multiplied to cosine squared theta times cosine squared theta, that will become cosine theta raised to the power of 4 divided by 1 minus cosine raised to the power of 4 theta, plus we have sine squared. We're going to multiply both numerator and the denominator with sine squared theta, so sine squared theta times sine squared theta will give us sine theta raised to the power of 4 times cosine squared theta whole divided by 1 minus sine theta raised to the power of 4. Now we'll be combining the two terms, so our denominator is going to be 1 minus cosine theta raised to the power of 4 multiplied to 1 minus sine theta raised to the power of 4. So that means in the numerator the first term will be sine squared theta times cosine theta raised to the power of 4 whole multiplied to 1 minus sine theta raised to the power of 4, plus the second term will be sine theta raised to the power of 4 times cosine squared theta whole multiplied to 1 minus cosine theta raised to the power of 4. Further simplification is going to give us, so we have in the numerator sine squared theta times cosine theta raised to the power of 4 multiplied to 1 minus, we have sine squared theta times sine theta raised to the power of 4, so that's going to give us sine theta raised to the power of 6 times cosine theta raised to the power of 4, plus we have sine theta raised to the power of 4 times cosine squared theta multiplied to 1 minus cosine theta raised to the power of 4, which should give us sine theta raised to the power of 4 times cosine squared theta minus, we have sine theta raised to the power of 4. Now we have cosine squared theta multiplied to cosine theta raised to the power of 4, which is going to give us cosine theta raised to the power of 6 whole divided by, we have 1 minus cosine theta raised to the power of 4 whole multiplied to 1 minus sine theta raised to the power of 4. Fine. So we're going to combine the first term and the third term of the numerator. For that we are going to consider sine squared theta times cosine squared theta as the common factor. So here we'll have cosine squared theta plus sine squared theta. Then we're going to combine the second and the fourth term by taking negative sine theta raised to the power of 4 multiplied to cosine theta raised to the power of 4 as the common factor. So this will get multiplied to, so in the second term we have taken sine theta raised to the power of 4, cosine theta raised to the power of 4 is the common factor, so we'll be left with sine squared theta, and from the fourth term we'll be left with positive cosine squared theta whole divided by, we have 1 minus cosine theta raised to the power of 4 times 1 minus sine theta raised to the power of 4. So let's combine them. So we're going to multiply them, so we have 1 minus sine theta raised to the power of 4 minus cosine theta raised to the power of 4 plus cosine theta raised to the power of 4 times sine theta raised to the power of 4. Right. Now we know that cosine squared theta plus sine squared theta, that's a standard identity, trig identity with a value of 1. So here in both the cases we're going to get sine squared theta plus cosine squared theta equals to 1. So we have sine squared theta times cosine squared theta minus sine theta raised to the power of 4 times cosine theta raised to the power of 4 whole divided by 1 minus, so we're going to take negative common and combine the second and the third term. we have sine theta raised to the power of 4, which can be also expressed as sine squared theta whole squared, plus cosine theta raised to the power of 4 can be expressed as cosine squared theta whole squared, plus cosine theta raised to the power of 4 times sine theta raised to the power of 4. Now we'll do more simplification here. In the numerator, we will take sine squared theta times cosine squared theta as the common factor. So this will get multiplied to 1 minus sine squared theta times cosine squared theta, divided by, we have 1 minus. Now the whole reason we wrote it as in this format, sine squared theta whole squared, because we know that whenever we have a squared plus b squared, so that is equivalent to a plus b whole squared minus 2ab. So in a case, a is equivalent to sine squared theta and b is equivalent to cosine squared theta. So that means if we use this particular format, then sine squared theta whole squared plus cosine squared theta, this is b, whole squared will be equals to, so we'll have sine squared theta plus cosine squared theta whole squared minus 2 times AB. So AB will be sine squared theta multiplied to cosine squared theta. Now sine squared theta plus cosine squared theta, this is standard trig identity with a value of 1. So we're 1 squared, which is 1. This is going to give us 1 minus 2 times sine squared theta times cosine squared theta. So now that I have sine squared theta whole squared plus cosine squared theta whole squared in this particular format, so let's use this. So we have negative 1 plus 2 times sine squared theta times cosine squared theta. That will be now added to cosine theta whole raised to the power of 4 times sine theta whole raised to the power of 4. So the 1 and 1 gets cancelled out, and then this is going to give us sine squared theta multiplied to cosine squared theta whole multiplied to 1 minus sine squared theta times cosine squared theta whole divided by, we're going to take sine squared theta, cosine squared theta as the common factor from the two terms. So we have sine squared theta times cosine squared theta whole multiplied to 2 plus sine squared theta times cosine squared theta. Now we can factor out sine squared theta, cosine squared theta from the numerator and the denominator, and that finally leaves us with 1 minus sine squared theta times cosine squared theta whole divided by 2 plus sine squared theta times cosine squared theta. So this is the expression on the right hand side. Hence, we have successfully shown that our left hand side of the given expression is equivalent to the right hand side, hence proved.